Hello everyone, I hope you're doing great. My name is Adal and I'm excited to share this video with you. It is the first of a series of videos and we will be talking about 3D modeling and programming and how we can bring both together and automate the design process. In this introductory video, we'll be highlighting three aspects. We'll start by giving an overview of the scope of this video series. Next up, we will have a demo. This will by no means be an exhaustive demo. It'll just give you a sense of what you can expect once you've gone through this series. It is intended also to give you a general picture of what we will be covering and hopefully spark some ideas of your own. And finally, we'll discuss some prerequisites and the reason why I decided to put this together. All right, let's get to it. Stated in simple terms, we will be designing and coding an application from start to finish. And that application will control our 3D model. So we'll start from the very beginning, defining the purpose of the application that we will be designing. We'll establish a set of features that this application needs to contain. Afterwards, we will be discussing the design process. We will identify the various components that need to be created and then cluster together to produce the application that will ultimately drive our design. Along the way, also, we will be touching on 3D modeling, of course. We need to create a model to work with. And so basically, the approach that we'll be using, the workflow, is represented here where we have a user interface that allows us to select our design units and then uh, provides us a way to make different selections, enter different data, and then based on that data and selections that we make, it'll produce a 3D model as shown here. Now, full disclosure here, I am not a software developer. I am not a software developer or a software architect or things of that nature. My background is in mechanical engineering and 3D modeling, finite element analysis and hydraulic design, along with CFD. But I have always had a passion for programming, and I constantly try to improve my skills in this field. Now, having said that, I feel that I do have a bit of understanding of object-oriented principle and design patterns. So we'll be putting those tools to work, and we will also be implementing the MVC design pattern or model view controller design pattern in our application, and this will allow us to create an application that is loosely coupled, meaning that in the event, in the case that later on we need to migrate to another CAD system, most of our code, most of our code will be reusable. So this is a good thing. Basically, we will design our application such that each component is as independent as possible. We will be touching also on test-driven development or TDD to test our code. We will see the advantages and the assurance that it provides us when it comes to code refactoring. So that's a good thing that we will be using. And so if you feel like a little bit intimidated or concerned about these concepts, your skills are a bit rusty, don't worry. It'll make sense. It will click as we move along. On the other hand, if you have any comments or suggestions to improve the design or to improve the code, by all means, feel free to give feedback in the comments section below so that we all can benefit. Okay, so now let's jump onto the demo. Before we actually look at the 3D model and explain the main features of the application, let me give you a little bit of context. The part that we will be working on is this component right here. In my line of work, that is called a sole plate. And one of its function is to provide a flat and level surface onto which the machine sits on. It also transfers the loads of the equipment onto the foundation or the ground. Failing to do so will result in either premature or catastrophic failure of the system. So we will be working in automating the design of this component. And then once you understand the general concept, then we should be in a position where we can basically automate any part of this machine. All right, so let's just look at the tree model now. Let me flip to NX. And so we have our part here, our sole plate, and we have our initial screen, if you will, which allows us to select both units, metric or imperial. We'll select imperial for now. We'll come back to the units later on. So this is our main screen, our main interface with the model. So we will be using this window here to interact or drive this 3D model. Starting from the top section, we have various design workflows, all of which change how the user interface behaves. With this approach, engineering to order approach, the user will be able to enter selected values in selected fields, and the remaining values needed to fully define the component will be automatically calculated. On the pre-engineer mode, uh, we're talking about a standard part. So in this design mode, the application actually will connect to a database and will read all the values that it needs to fully define the component. Um, Finally, on the custom mode, the user will have all the freedom to enter or to define all the values as she or he sees fit. This is the most challenging mode to implement because the application will actually have to validate the data provided by the user, and if the values are not compatible, then it has to display a error message advising to correct the inputs. So we will look at the user validation process as well uh, while we write our code. So next up we have the configuration section, which is self-explanatory here. We choose the shape of our component, and we also have plenty of space to add more features if we decide to do so in the future. And finally, we have, well, not finally, but the next section is the general information section, in which we specify more of the general data for these components, such as cleanup diameter, width, the length, because it's a square, it's obviously the same as the width, and things of that nature. And finally, on the salt plate definitions section, we fully define our component. The process or this step is broken up in different sections. The mountain drilling definition, as you can see here, it defines the features that um, are related to the drilling, to the holes here, to locate those features onto the component. Foundation drilling definition also specifies each and every value that is needed to fully locate the feature onto the component. And finally, this section, which is very simple and is self-explanatory. As you may have noticed, we have several drop-down boxes here that they change their values and they update automatically depending upon the values that we've selected. And we will look at how to implement all of these values later on the as we make progress. Okay. Now, if we go back up here and we change the design mode to, well, we have it custom right now, but if we change it to a engineer to order, we see how some of the values get automatically disabled, and then we just need to define a few parameters. Basically, most of the values are auto-calculated. If we change to a pre-engineered component, then again, these options get disabled, and we are presented with these two fields or drop-down boxes to select whatever we want to select our desired size of salt plate, for example. And if we navigate to the next screens, we'll see that all the fields are disabled as expected because this is an existing part or a standardized part, if you will. So no, it has been fully defined. All right, so let's just give it a shot and see what happens. So let's just click finish. And the model updates. Yep, model updates. Let's go back again and do another example here. And this time, actually, let's go back and change the design mode to auto calculate the values. And let's just change the shape to rectangular. And as you saw, which you may have noticed, as soon as I changed to a rectangular shape, another section appeared. And that's because a rectangular salt plate has additional features. So here we have these options. We can either include or exclude these options here. And if we check or uncheck, the user interface will update so that only the required information is presented to the user. Also, as you may have noticed as well, the pictures have been updated as well. So for this case, let's include the seal system mounting holes, and let's just give it a shot here. Let's do 72 inner diameter. Let's do. Now, if we enter an incorrect value, for example, for the ID obviously must be smaller than the cleanup diameter or the width. But if we make a typo and we enter an incorrect value, the application will tell us that that's not a acceptable value. So we have to change, and it gives us a hint of what the value needs to be. So we hit OK, and as you may have noticed, the finish button is disabled. So we have to correct those errors before we can proceed further. So let's do 50, and yeah, the error goes away. Yeah, let's change the thread standard to UN, and let's do 1.25 here. Let's do 12, and notice how the values get automatically updated. Let's do 6 holes is fine, and let's change the value to 2 inches. Here we can say UNC, and let's do half an inch. Half an inch. Right, finish is enabled, so everything should be correct. Let's just hit finish. And then the model updates. One thing that I forgot to mention, or I forgot to um, show, is one of the sections that becomes available once we select a rectangular solid plate, and that's the cell system mounting definition. So in this area, we have the opportunity to change the values as we need to. So I'll just leave it the way it is. But yeah, this is the application that we will create from start to finish. As we have been shown, that's pretty much what you will accomplish by the end of this video series. And we will make some adjustments as we progress. But yeah, that's pretty much the functionality that the application needs to implement. All right, let's go back to the prerequisites and the reason why I decided to put this together. And let me start with the reason, or with the why I decided to put these videos together. And as we discussed, designing an application like this one involves multiple disciplines, all of which I am passionate about. And there is plenty of information out there about these topics. And while much of that information is great, I often found myself jumping back and forth, investigating and trying to understand how things fit together. And that required a decent amount of time and effort on my part. And so the objective of these videos is to bring things together and show everything as a whole, with the intent to cut down the time that students or people in general need to invest in order to improve their skills. Now, the prerequisites are a few. The first one, and most important in my opinion, is the desire to learn. That will be the driving factor in my opinion. Uh, Another requisite will be basic programming skills, or basic to intermediate programming skills. NX knowledge, as you saw, we will be using NX. I'm working on version 10. However, the code should be able to run in newer versions as well. We will be using C# as programming language, and also if you have a basic understanding of object-oriented principles, that will come in handy as well. Of course, we will be using Visual Studio, and you can download it for free. The community edition is free, and you can use that to follow along during the coding section of this series. Yeah, that's it for this video. I think we covered the basics, and yeah, in the next video we will discuss the architecture of the application and discuss how we expect it to work. Until then, thanks for watching.